dynamic encryption key generation. In this video, we will cover this topic briefly. So we have already learned that the purpose of .1x is authentication and authorization, right? That's pretty much what it is doing. In the last video, last chapter, we figured that out. .1x is doing authentication and also authorization, correct? This is what it is doing. However, this is not what it does. This is not all that it does. There is a byproduct of .1x that is generated and distributed called the dynamic encryption keys. Okay, there is a byproduct that is generated and distributed, okay, called the dynamic encryption key. So if you remember that entire flow that we talked about in the last chapter, there was at the end the four-way handshake happens and the dynamic encryption keys are generated, right? That's the byproduct of EAP authentication. Now, so EAP protocol that utilizes that utilizes mutual authentication can provide seeding material that can be used to generate these keys. Okay, this basically happens in mutual authentication, okay, where it becomes as a seeding material and which can be used to generate these keys at the end. So far till now what we had learned was about static web keys, right? If you remember, we spoke about static web keys in a few chapters. So now static web keys by far is a big nightmare for network administrators, right? I mean, nightmare for admins, wireless admins, because of many reasons. I mean, the key, most of the clients use a single key, and if the key gets compromised, then you're looking at a lot of issues, and you basically have to reconfigure everything, and that's kind of a big task for any network admin. So it's because of the social engineering problems that static web keys are also not used, and of course they're also not very stable and safe, right? So the advantage of dynamic keys is that every user has a different and unique key, and which cannot be compromised using social engineering, correct? So every user has a different and unique key anyway. So that's the advantage of having a dynamic key, right? So for dynamic key, every user has a different and unique key. Right, this makes the social engineering problem go away. So anyway, yeah, so this is the advantage of dynamic key. Now after the EAP frame exchange has happened, where mutual authentication is required, both the AS and the supplicant know quite a bit about each other, right? Because they actually exchanged the frames between them. So once the EAP exchange has happened, EAP exchange has happened, the AS and the supplicant have exchanged credentials, right? Now they know pretty much a lot of things about each other, right? Now this newfound information, so supplicant has given them, let's say, username and password, AS has given them certificate, digital signed certificate, and username and password supplicant has given, and AS, as I said, has given the certificate to the supplicant to verify its identity, right? Now this newfound information can be used as a seeding material or a keying material to generate the matching dynamic keys for both AS and the supplicant. Now this newfound information becomes a seeding material, okay, for dynamic encryption keys. Okay, this is what it really does. Now these dynamic keys, there's something special about these keys are that these are, let me just write that down, these dynamic keys are generated per session per user, meaning that every time a client station authenticates, a new key is generated and every user has a unique and separate key. Okay, it's per session per user. So these keys are generated per client per session. Every time a client authenticates, it's going to generate a next set of keys so that they are not used again. Okay, so this is a brief about dynamic encryption keys. In the next chapter, I'm going to cover four-way handshake and we'll see how that really works out.